Making our way through the Blender 4.0 documentation, we are going to take a look at pivot point controls in the 3D editor. And just for the sake of transparency, the documentation did a lot of heavy lifting in this video. Before we begin, let me just take a moment to express gratitude for your being here. If you like educational content like this and wish to support the channel, please leave a like and a subscribe. It helps out a lot. And thank you. This lesson is relevant to the object mode and the edit modes of the 3D editor in particular. If you recall in the video where we went over the Blender interface, we saw this guy in the header here. And we learned that you can use the hotkey period on the keyboard to get the same result. So, let's dive in. What is a pivot point? The pivot point determines the location of the object gizmo, or if it helps, the object itself. Changing this location can make it easier to perform transformations around a point that you want to pivot around. Again, recall from earlier lessons that if you change the pivot point to, say, the 3D cursor and try to rotate the object, it will rotate around the 3D cursor instead of the midpoint, like where you would typically expect. We see a few options that we can change the pivot point to. The first being the bounding box center. In this mode, the pivot point lies at the center of the bounding box, which is a box that's wrapped as tightly as possible around the selection while still being aligned to the world axis. If you have experience with colliders in video game engines, then think of that. In object mode, the pivot point becomes the center of the bounding box around the selected object's origin points, not their geometry. This means that if you have a single object selected, the pivot point is the same as the object's origin point, which can be customized and doesn't have to be in the center. In the example below, the orange rectangle has it in a corner instead. If you have multiple objects selected, the pivot point becomes the center of an imaginary box around their origins. The image that you see on screen is lifted directly from the documentation so that it can be more easily explained. The image shows the difference between bounding box center and median point. The latter calculates the average position of the origins, meaning that the pivot point shifts towards the area with the most objects. On the left is the difference between bounding box center. On the right is the median point. If you remember in math class, you learned the median is just the middle, so to speak. Not actually, but I hope you get what I mean. In edit mode, the pivot point becomes the center of the bounding box around the selected mesh elements. This image illustrates the effects of rotation in different mesh selection modes. A yellow circle shows the pivot point. The median point may again give a different result. This image illustrates the difference between bounding box center on the left and median point on the right. Seeing as that we have already seen how setting the pivot point to the 3D cursor works a couple of times now, I think it might be safe to skip over that one. What happens when we set it to individual origins? While the other pivot point modes transform the whole selection around one point, individual origins transforms each item around itself. In object mode, each object gets transformed around its origin, which is a point that can be chosen freely and doesn't have to be in the center. In the example below, the orange rectangle has it in a corner instead. Take a look at the following images. This is a rotation around individual origins. As you can see, the points here are where the objects in the image pivot from. The images that will be shown here now compare individual origins to the median point. And now, in order from left to right, the starting situation, rotation around individual origins, and rotation around the median point. And this time the same thing, left to right. The starting situation, scaling using individual origins and scaling using the median point. And now we will see how this works in edit mode. Each selected element is transformed around its own center point. The starting situation, rotation around individual origins, and rotation around the median point. The starting situation, scaling using individual origins, scaling using median point. When you transform adjacent faces or edges, they are treated as a single element, meaning they don't become disconnected. And next, the median point. In object mode, origins can be chosen freely and can even lie outside their object's geometry, so that the median point is not always what you might expect. And in edit mode, the median point is the averaged out position of the selected vertices. This means that the pivot point will shift towards the area with the densest geometry. In edit mode, the median point is the averaged out position of the selected vertices. This means that the pivot point will shift towards the area with the densest geometry. In the example on screen, the pivot point lies perfectly in the middle, if both cubes have the same number of vertices, but heavily leans towards the side if one cube is subdivided, even though both cubes still have the same size. And lastly, there is the active element to pivot on. I'll wager that you might guess how this will work. I won't go over it now, but basically the objects in the scene will pivot around the center point of the selected object. This can be your homework for today. Give this one a try. That's all for this video for the pivot points in the 3D editor. Thanks for making it all the way through the video. Join us in the next video as well. If you like content like this, please be sure to support the channel by liking and subscribing. See you in the next video.